guys, lesson number 12, relationships between two numerical variables. This one is a little bit shorter than the last lesson, so go ahead and make sure you have lesson 12 out in front of you. And let's go ahead and look at this. We're going to distinguish between scatter plots that display a relationship that can be reasonably modeled by a linear equation, and those that should be modeled by a nonlinear equation. Alright, so a scatter plot is an informative way to display numerical data with two variables. In your previous work in grade 8, you saw how to construct and interpret scatter plots. Recall that if two numerical variables are denoted by x and y, the scatter plot of the data is a plot in the x-y coordinate data pairs. Alright, so let's go ahead and look at example number 1. Looking for patterns in a scatter plot. The National Climate Data Center collected data on weather conditions at various locations. They classified each day as clear, partly cloudy, or cloudy. Using data taken over a number of years, they provided data on the following variables. X is the elevation above sea level in feet. Y is the mean number of clear days per year. W is the mean number of partly cloudy days per year. And Z is the mean number of cloudy days per year. Alright, so go ahead and let's look. Here we've got a table that shows data for 14 U.S. cities. Alright, so go ahead and take just a minute and look at that data. We're not going to spend a whole lot of time me in the video looking at it, but please make sure you've looked at it. And then go ahead and look at the scatter plot that they have created based on the elevation and mean number of clear days. Alright, so we've got our x, y here. Alright, so let's go ahead and look at exercise number 1. Do you see a pattern in the scatter plot, or does it look like the data points are scattered? Alright, so let's kind of look at this and see, do I see a pattern in my scatter plot? In other words, do they all kind of seem to follow a same pattern, or are they kind of almost like somebody has taken paint on their hand and just flung them? Alright, you will see it kind of has a small pattern, but it is not a strong pattern. Alright, so it does kind of look like there's a small pattern. Here it kind of looks like they are scattered, but here's what we want to look at. So let's go ahead and write that down. There's not a strong pattern. Alright? So it's not a strong pattern. But here's what we do want to look at. There is a pattern that suggests as the elevation increases, what happens to the number of clear days? The number of clear days also increases. So we do kind of see that pattern there. Alright. Question number 2. How would you describe the relationship between elevation and mean number of clear days for those 14 cities? That is, does the mean number of clear days tend to increase as elevation increases, or does the mean number of clear days tend to decrease as elevation increases? Well, we just talked about that. As the elevation increases, the number of clear days increases. Do you think that a straight line would be a good way to describe the relationship between the mean number of clear days and elevation. Why do you think this? Okay, so in other words, what they want to know is, can I draw a straight line through my data and be fairly close to all data points? I am not going to be able to draw one straight line through the whole entire chart and touch every single point. But can I draw a line through my data that will be close? In this case, although the pattern is not strong, the straight line would describe a general pattern. Alright, so I could create a straight line through this and it would give me a general pattern of my data. Alright? Alright, let's look at this. Thinking about linear relationships. Below are 3 scatter plots. Each one represents a data set with 8 observations. The scales on the x and y axes have been left off these plots on purpose, so you will have to think carefully about the relationship. Alright, so looking at these. If one of these scatter plots represents the relationship between height and weight for 8 adults, which scatter plot do you think it is and why? Alright, so let's think about height and weight. A lot of times as height, as you get taller, you start to weigh more. So which one of those would show that? Scatter plot 1 would show that if I let x be my height and weight be my be my y, then as my height gets taller, my weight goes up. Alright? What about this one here? Could I do that with this one? I don't think I could use scatter plot 2. But scatter plot 3, once again, if I let x be my height and y be my weight, this could be. Alright, so we're going to say scatter plot 1 or scatter plot 3. Scatter plot 3 would work because not everybody, as they get taller, weighs more. Alright, some people, as they get taller, they actually lose weight. So we could use scatter plot 3. Alright? If one of these scatter plots represents the relationship between height and SAT math scores for 8 high school seniors, which scatter plot do you think it is and why? Well, let's think about this. Is there a relationship between height and their ACT or SAT math scores? No. So that would be scatter plot 3. There is no relation. Okay? No relation between those two. Alright, let's look at number 6. If one of these scatter plots represents the relationship between the weight of a car and the fuel efficiency for 8 cars, which scatter plot do you think it is and why? Well, let's think about this. If you don't know a whole lot about cars, basically the more the car weighs, the more gas you're going to use. So as my car weight increases, my fuel efficiency decreases. So scatter plot 2 would work here. As the car weight increases, fuel efficiency decreases. Okay? Which of these three scatter plots does not appear to represent a linear relationship? In other words, which of these can I not use a straight line to describe the relationship? Scatter plot 3. Alright? Because there is no relation. So I cannot use a linear equation or a linear relationship here. Alright. Exercises 8 through 13. Not every relationship is linear. When a straight line provides a reasonable summary of the relationship between two numerical variables, we say that the two variables are linearly related, or that there is a linear relationship between the two variables. Take a look at the scatter plot below and answer the questions that follow. Is there a relationship between the number of cell phone calls and age, or does it look like the data points are scattered? Well, let's look at this. Does it kind of look like it fits in a line? There is a relationship. Okay? If there is a relationship between the number of cell phone calls and age, does the relationship appear to be linear? Well, does it look like I could draw a straight line through my data and be close to most of my points? Yes. So the pattern is linear. Alright? Alright. Let's look at scatter plot 2. Looking at this, question number 10 says, is there a relationship between moisture content and frying time, or do the data points look scattered? Once again, it may not be linear, but do they look like they form a pattern? There is a relationship. Let me go back and kind of show you. So if I were to draw a line, it kind of looks like my data goes in a line. But here, look at this. As the frying time gets longer, the moisture comes out. I see that pattern. Alright? If there's a relationship between moisture content and frying time, does the relationship look linear? Alright? So as the frying time increases, the moisture content decreases. In other words, my food's getting drier. But look at my data. It's not linear. It is not linear. Alright? Have we seen this shape before? This is what we call an exponential curve. Alright? An exponential curve. Alright? Alright, last one. Look at this. How would I describe this scatter plot? Well, to me it kind of looks like somebody put paint on their fingers and went, and that's where they landed. Scatter plot 3 shows data for the prices of bike helmets and the quantity ratings of the helmets. The quality ratings of the helmets, based on a scale that estimated helmets quality. Is there a relationship between quality rating and price, or are the data points scattered? Alright, is there a relationship? So in other words, as the price increases, does the quality rating go up or down? No. Guys, it is so all over the place. So there is no relationship here. If there is a relationship between quality rating and the price for the bike helmets, does the relationship appear to be linear? So it's not linear because it's not linear, or it's not. Okay. It is neither linear nor not linear because there is no relationship. Alright, so scatter plot can be used to investigate whether or not there's a relationship between two numerical variables. A relationship between two numerical variables can be described as a linear or a non-linear relationship. Alright guys, that's the end of lesson 12. Hope you have a great rest of the week and an awesome weekend.